बिस्मिल्लाहिर्रहमानिर्रहीम अऊज़ु बिल्लाहि मिनश्शैतानिर रजीम बिस्मिल्लाहिर्रहमानिर्रहीम नहमदुहु व नसल्ली अला रसूलिहिल करीम अल्हम्दुलिल्लाह. In the last lecture we have completed the SAR of sulfonamides. We have got a number of derivatives of sulfonamides and the parent compound is sulfonylamide. The parent compound is sulfonylamide. I have told you that we have synthesized thousands of derivatives, but out of those only few are in clinical use. The main problem, the main toxicity of these derivatives is the crystalloruria. Crystalloruria is the term which is used for the formation of crystals. In the last lecture, in the end of the lecture, I have told you that generally when we are using the sulfonamides in the case of UTI, urinary tract infections, the pH of the urine is less than the physiological pH. What does it mean? The physiological pH of the urine is about 6.1 or around 6, but in the case of infection the pH is about 5, while the pK of sulfonylamide is 10.4. As we have already seen that the pK value is one method used to indicate the strength of an acid. pKa is the negative log of the acid dissociation constant, or Ka. A lower pKa value indicates a stronger acid. The lower value indicates the acid more dissociates in water or completely dissociates in water. To overcome the problem, we have got certain strategies. For example, the physicians and the pharmacist advise the patient to increase water intake or force to take more and more water. More and more water. While the second strategy is to use a compound which can increase the pH of the urine. For this, we use oral sodium bicarbonate, one of the commercially available compound or drug is the cetrilca, which can be used for this purpose. What does it mean? Why we are increasing the pH of the urine, or why we are reducing the pK of the compound? When we have investigated why the crystals are formed in the urine, it was found that the difference between the pH of the urine and the pK of the compound will play a role. As the difference is higher, the formation of crystals is more. What does it mean? The pH of the urine and the pK of the compound should become closer as much as possible, and if this will take place, this will occur, the formation of crystals in the urine can be inhibited. In the first strategy, we have forced the patient to take more water that will dilute the urine, while in the second strategy, we have directly tried to increase the pH of the urine. Why? We are talking about the parent compound. The pK of the parent compound is 10.4. Hence, just we are increasing the pH of the urine so that it come closer and closer to the pK of the sulfanilamide, that is 10.4. What does it mean? The pH, which is 5, will be increased, or pH will reach to the pK value, that is 10.4. For this, we can use oral sodium bicarbonate, Ceritralka, or some other measures can be used for this strategy. But as a medicinal chemist, we don't appreciate these approaches, these strategies, because we want to synthesize the compounds, the derivatives, which have a lower pK value, closer to the pH of the urine. And in the last strategies, we are increasing the pH of the urine, and in this strategy we are decreasing the pK of the compound. The purpose of both of these strategies is to make the pH and pK closer as much as possible. We have synthesized a number of compounds in which the pH of the urine, or we can say the pK of the compound, the pK of the compound is decreased. For example, we have got a number of compounds such as sulfamethoxazole. The pK values is 6.1. Sulfamethazole, sulfasoxazole. In the case of sulfasoxazole, the pK value is 5. That is just closer or almost equal to the pH of the urine, while the other compounds such as sulfacetamide, the pK value is 5.4. Sulfamethoxazine, pK value is 7.2. Sulfamethoxazole, pK value is 6.1. Sulfadiazine, the pK value is 6.5. While for the same purpose, we are also using the number of sulfonamides, or we use different derivatives in combination, such as a mixture of sulfadiazine, sulfamerazine, and sulfamethoxine can be used. Now, the question is that we have got the molecules which have got the lower pKa value, but how can we achieve this goal? It was found that by introducing electron withdrawing group at the place of H of the SO2NH2 group, which is attached to the aniline or aromatic ring, will result in the desired molecule. Electron withdrawing groups withdraw the electrons. The hydrogen which is present or remains with the SO2NH will become more acidic, and by this it will become more water soluble. Why we are only introducing the aromatic rings or heterocyclic rings, maybe 5-membered or 6-membered, whether we can use the other electron withdrawing groups? Yes, it can be possible. We can use the other groups. One of the example is para-nitrophenyl, but we have observed that by introducing such type of the groups, the compound become toxic or insufficiently active, or both. What does it mean? Insufficiently active as well as too toxic to be used as a medicine. And hence, after observing thousands of derivatives, we have finally found that the substitution of 5 or 6-membered heterocyclic ring will be the most suitable substituent for this purpose. We have synthesized a number of derivatives just to reduce the pKa value, and we have got the compounds. Then we have classified the sulfonamides on different bases. One is that on the basis of pharmacokinetics, that is absorption and excretion of the molecule. For example, we have got the compounds like sulfamethoxazole, sulfamethoxazole, sulfadiazine, which are absorbed and excreted rapidly. They are going to be absorbed rapidly, and they are also going to be excreted rapidly. Generally, in this case, the repeating dose is 6 hourly, or repetition of the dose is after each 6 hours, or we say QID. Poorly absorbed, such as sulfasalazine, Sulfasalazine is one of the examples in which the compound is not absorbed in the small intestine. It will reach to the bowel or to the large intestine. In the large intestine, by the action of microflora, sulfasalazine is metabolized and the active ingredient will be released. We have got certain compounds such as sulfadoxime, not doxine, doxime. Instead of N, you should read it M. Sulfadoxime, sulfadoxime. This is one of the long-acting compounds. We have got the compounds which can be used maybe after 1 week or once in a week. Then the compounds can be classified on the basis of their site of action. For example, the compound sulfacetamide is used in the cases of eye infection, or sulfacetamide is present in ophthalmic preparation. Sulfasalazine is used specifically for ulcerative colitis. Sulfamethoxazole, sulfacetamide, they are commonly used in the case of UTIs. Why I have just told you that sulfacetamide is one of the compound which is also used in ophthalmic preparation. Another compound is sulfapyridine. The compound is too toxic, but in some cases it's used to treat a pneumonia patient. Then we have got certain compounds which are used topically. Generally, these compounds are used as burn therapy. Before that, we have discussed the sulfacetamide that can also be classified in the same class, topical or topically used agent or topical agent, but that is in the ophthalmic preparation. Here we have got at least two specific compounds. One is silvadene, that is silver salt of sulfur diazine. This compound have got the activity of silver as well as sulfadiazine. The compound is active against Pseudomonas, specifically used in the cases of burn. It is used in the form of water miscible cream, cannot penetrate the cell wall. Salt is slightly soluble in water. Just We have classified the compounds. I have given you few examples, but now we are going to deal with the different derivatives, including these, or the derivatives which have got the different absorptive rate or different site of action.